So for the first example, we want to find a polynomial function f of x of degree 3 with real coefficients and that satisfies the following conditions. Now this is part A, so we're going to do two parts, a part A and a part B. So for the first part, the conditions are -1, 2, 4. Those are zeros, and f of 1 equal 3. So the zeros help me to be able to write out the factors, but this additional piece of information, which gives me a point on the graph, helps me to be able to figure out what the leading coefficient is. So since it's a polynomial of degree 3, then by the fundamental theorem of algebra, I know that this polynomial will have 3 factors. And in each of those factors, there will be a 0. But again, remember, a 0 can count more than once. But for this particular problem, it gives us 3 zeros. And by the number of zeros theorem, that's all the zeros we can have. Because it's a third degree polynomial, the most amount of zeros you can have is 3. So these are all the zeros. So since -1 is a 0, then x minus -1 is a factor, and that's by the factor theorem. Or we can use that here. That's where this comes from, the factor theorem. X minus that number is a factor. So that's what this k1 come in, and x minus k2, which is 2, and then x minus k3, which is 4. So that gives me those factors. So we get f of x is equal to a times x plus 1 times x minus 2 times x minus 4. So the only thing we need here now is to figure out what is a. And we can figure out what is a by using this fact that f of 1 is equal to 3. So this gives us the point 1 comma 3, because your x is 1 and your y is 3. When you plug in 1, you get out 3. So this is the point on the graph. So that means whenever I replace my x's with 1, my f of x will be equal to 3. So I'll replace f of x with 3, and I'll replace every x with 1 so that I can figure out what does a equal. And a is the leading coefficient. So we end up with 3 equal to a times 1 plus 1 is 2. 1 minus 2 is -1, and 1 minus 4 is -3. Multiply those together. 2 times -1 is -2. -2 times -3 is +6. So 3 is equal to 6a. In order to solve for a, we need to divide both sides by 6. So we get a is equal to 3 over 6, which can be reduced to 1 over 2. So our a is equal to 1 over 2. So that means our function looks like this. F of x equal 1/2 x plus 1, x minus 2, and x minus 4. All right, so that's our function in factored form. Now, sometimes your homework may not want you to write it in factored form. It may want you to actually multiply that out. So I'm going to show you how to go through and multiply that out. So I'm going to erase this so that I can use this space to actually multiply that function out. So what I want to do is start with multiplying the first two, the x plus 1 and the x minus 2. And I'm going to do it over here on the side. What is x plus 1 times x minus 2? Well, that's two binomials being multiplied. FOIL it out. X times x is x squared. X times -2 is -2x. And x times 1 is +1x. And 1 times -2 is a -2. So if you combine like terms, -2x plus x is -x. So I'm going to replace these two with x squared minus x minus 2. So now I need to multiply these two. And so you can do this times everything over here, this times everything over here, and this times everything over here. But I like to use the box method when multiplying long polynomials. So I'll put x squared minus x and minus 2 here. And I'll put x and minus 4 here. And then just multiply what's on top and on the side. So that'll be x to the third minus x squared minus 2x. That will be minus 4x squared, +4x, and +8. And so that will give me 1/2 times x to the third. Combine these two because those are like terms. -4 and -1 is minus 5x squared. 4x minus 2x, those are like terms. That'll be plus 2x, and then plus 8. 8 has nothing to be combined with. And then you will distribute the 1/2. I know it's a lot of steps. So you would distribute the 1/2 and you'll get 1/2 x to the third minus 5/2 x squared. 1/2 times 2 is just 1x, and 1/2 times 8 is 4. So this is what your polynomial would equal actually multiplied out, okay? So this is what it would equal in factor form. If it wants you to put it in factor form, you could have stopped here. But if it wants you to actually multiply it out, this is how you will go through and multiply it. Ta-da! Okay, for this second part, so we still have the final polynomial function of degree 3 with real coefficients that satisfy the following. So it's still a third degree polynomial. This time we have different conditions that it satisfies. This time -2 is a 0, but -2 has a multiplicity of 3. So remember, I mentioned earlier that multiplicity means how many times that 0 is counted in the factors. And then it gives us this additional point to be able to find the leading coefficient. So because it's a third degree polynomial, remember it can be written as a times x minus 1, k1, x minus k2, and x minus k3, where k1, k2, and k3 represent your zeros. They only give us 1 0, which is -2, but because it has a multiplicity of 3, that means -2 counts 3 times. So you write -2 3 times. X minus a -2 becomes x plus 2. And because you have x plus 2 3 times, and that's supposed to be equal, you can also write this as a to the x plus 2 to the third. So because it gives us this point, this lets us know that -1 4 is on the graph of this function. So this lets me know whenever I plug in x, a -1 for x, I'll get out 4 for f of x. So I'll replace f of x with 4. I'll replace x with -1 in order to solve for a. -1 plus 2 is a +1. So that becomes 1 to the third, which is just 1. So you end up getting that 4 is equal to a, or a is equal to 4. And so your function ends up being f of x equal to 4 times x plus 2 to the third. So that's your function in factored form, and that came from here. All I did was replace the a with 4. So that's in factor form. Now remember, it might ask you to multiply it out. If it asks you to multiply it out, then you will need to go through and multiply step by step. So I'm going to erase that so I can use this space right here. So f of x would be equal to 4 times x plus 2 times x plus 2 times another x plus 2. So I'll start with, what is x plus 2 times x plus 2? Well, for that out, that's x times x, which is x squared. X times 2, which is 2x. 2 times x here, which is 2x. And then 2 times 2, which is 4. Combine your like terms, 2x and 2x, and you get 4x. So I'm going to replace these two x plus 2's with that x squared plus 4x plus 4. And so now I need to multiply these two. And again, I'm going to use the box method in order to multiply those out because they're pretty long. X squared, 4x, and 4, and then x and plus 2. So all these are positive, so that's why I didn't write the sign at first. But x squared times x is x to the third. So I'm multiplying what's on top and what's on the side. That'll be 4x squared. That'll be 4x. That'll be 2x squared, 8x, and 8. And so what I'll end up getting is 4 times, I still have my 4 in front. And so now I'm going to write what's left in the box, x to the third. And then your like terms are usually in a diagonal. So 2x squared and 4x squared is 6x squared. 8x and 4x is 12x. And then you have 8. And you would need to now distribute the 4 to all of those. So you would get 4x to the third plus 24x squared plus 48x plus 32. That's what your function will be equal to multiplied out. 4x to the third plus 24x squared plus 48x plus 32. Hopefully you get the steps of how I walk through those. If you have any questions whatsoever, please feel free to put them in the comments below. If this video was helpful, I don't know if I'm gonna get any likes on this one, but if it was helpful, hit a like, hit the like button. And if you haven't already, I'm pretty sure you have by now, but if you haven't, if you're new to the channel, go ahead and subscribe, show some love. Again, thanks for tuning in. I really appreciate it, and I hope this is helpful to you, and I will see you all in the next video.